Okay, now in one way or another, all that is worth thinking about. However, we can also go to our original table and look at A and C, because all three of these readings took place on the same trip. From 3 to 9 is 6, from 4 to 0 is 6. And if you go down through the whole list, from 9 to 5 is 9, then 0, 1, 2, 3, 4, 5. There are 6 changes there. So every one of these comes out 6. Well, this is very unhelpful in one sense. It's very unhelpful because we should be able, from this information, to limit this thing down to a range either from 5 to 6 or from 6 to 7. But so far, we have no evidence that allows us to do that. Now, what we do have is we don't see any 5s or 7s. So what we could probably do at this stage, let's see. For the first 11, all distances from AC are 6, which means that that's going to at least probably narrow our range. It's very, very unlikely that it's closer to 5 than it is to 6, and very, very unlikely that it's closer to 7 than it is to 6. To get either of those results would mean that essentially we flipped a coin 11 times and always came out heads. Okay, you might think of that analogy. It's a little hard to think of when you're not used to it. Okay, but it's worth thinking about. So from the first 11, all these are here. So I think we'd be comfortable at least in saying we're closer to 6 than we are to 5, or we're closer to 6 than we are to 7. So that our range of probabilities narrows considerably. Now, there are more data points. We've only got about roughly half of them listed here. If we see a case where the difference between here and here is 7, then that limits our probabilities between 6 and 7. Still probably closer to 6 than to 7, but that would limit us into this range. If we see a case where the difference is 5, where there are 5 changes, then that means our actual distance is between 5 and 6. So this whole probability is going to collapse on one side of the 6 or the other, and we don't know which side. We have to look further in the data, and if they all come out 6s, well, you know, if we get 11 more trials where they're all 6s, that's going to narrow this range a little bit. In fact, that would range it a whole big bit. Okay, it would make the range very narrow around 6, the range of likely outcomes. Okay, well, later on we see a 2 and a 7. Okay, so we see a 2 and a 7 here. Now, that indicates that it is possible to have only 5 changes between point A and point C, which means that the distance from A to C can't be as much as 0.6, because if it was, we would have to have 6 changes in that number on the odometer. The other thing, and you can think about it, what's the number in the middle here have to be? Okay, this number is determined from the other information that we have. Okay, summarizing the new information we get, if we look at all the rest of the information on the table, we see that the distance from A to C actually was indicated as 5 rather than 6. The first 11 were all 6s, but later on we got 3 5s. Okay, so 3 times out of 23, distance from A to C indicated 5. 12 times out of all 23, distance from A to B indicated 3. Okay, so that was about 50-50. From A to B, it was about 3. And that kind of confirms our suspicion that the distance from A to B is pretty close to 2.5. Okay, that's just about half and half. On 8 out of the 23, that's approximately 1/3 of our 23 observations, distance B to C indicated 4. Now that indicates, if that result holds up, that the distance is probably closer to 3 than it is to 4 between point B and point C. In the case of the distance from A to B, it doesn't really have too significant a change on where the center of this curve ought to be, but it does narrow our curve. We're quite a bit more sure, based on 23 results, that we're pretty close to halfway. So I'm going to say, well, our new information narrows our curve down like this. Now, I drew it lower, but that doesn't mean anything. The total area under this curve is still 100%. There were 100%. There's going to be somewhere under this curve, just as we are under this curve. Just a different scaling with the different colors. The scaling's unrelated to the color we use. Okay, well, but here on 8 of 23, distance from B to C was 4, meaning on the majority, almost 2/3, the distance was 3, which means that not only do we want to shift the peak of this curve over a little bit, maybe to about here, but we probably want to make the curve somewhat narrower, so maybe something like this. We're not totally sure it's under 3.5, but there's a pretty good chance that it is. We have less relative statistical fluctuation on 23 trials than we do on just 11. So our ideas, our conclusions are getting more certain as we have more and more trials. Also, this picture collapses significantly. So I want to redraw that. Here's our distance from A to C. Now we know it's between 5 and 6. Now we think that it's pretty close to midway here, and we think it's not all that far from midway here, so we're pretty sure it's closer to 6 than it is to 5, and I guess maybe it'd be time to bring the board over here where we can see it better. So here's 5, and here's 6. On only 3 out of 25 was the distance from A to C indicated as 5. That means almost 90% of the time the distance indicated 6, meaning that we're probably a lot closer to 6 than we are to 5, and maybe we want to draw our curve something like this. Now there are subtleties in the way we would draw this curve based on how close we are to 6, because we know 6 is an upper limit, and that's actually going to skew the curve a little closer to 6 and spread it out on the side of 5, but not taking all that into account, just drawing a rough, almost normal distribution type curve, we have this idea. Okay, now I'm going to make a reasonable stab at a conclusion. Now, I don't know how close this is to the curve that we would actually predict, but there is a way of predicting just exactly what that curve should look like based on 23 observations, what the probability distribution of the actual distances would be. We don't know how to construct that curve, but I can say that if that is the curve, and again, this is just something I came up with out of my head, it's probably not too awful far off, but I'm going to say that it looks to me like 90% of the area under that curve lies between here and here. Now, what are these limits? That looks like about 5.7. That looks like about 5.9. Now, that's just eyeball estimate, okay? So, from an eyeball estimate of an intuitively sketched curve, now it's based on some analysis here, but this is all intuitive, okay? So it's nothing very reliable. Just to get the idea, though, of how this, an overview of how this sort of thing could be analyzed and intuited. I say that 90% of the area of the curve lies between this line and this line, and eyeball estimate, this is 5.7 and this is 5.9. So our reasonable stab at conclusions would be that we're 90% sure that the distance is between 5.7 and 5.9 units. 5.7 and 5.9 1/10 mile units. So I've written the statement. We're 90% sure that the distance is between 0.57 and 0.59 miles. Remember, this is 5.77 tenths of a mile, 5.9 tenths of a mile. I chose to write these numbers in terms of tenths rather than in terms of miles, just because it's easier to deal with whole numbers. I think it's easier to you to focus, but you should understand now that since these measure tenths, that's our estimate. Now we can also estimate that 90% area here and here. Looks like it goes from about 0.24 to about 0.27 on this scale, and about 0.325 to about 0.345 here. The way I've drawn it. Now, again, very unreliable and intuitive. All this could be determined by analysis. We could get our 90% level of certainty for each of these distances based on the data that we have on 23 trials. If we used a greater number of trials, we would have a narrower range on each of these. If we did this for 1,000 trials, we'd probably be pretty close, maybe within 1/100th of a mile. Interesting question for you to ponder just conceptually. Okay, if we add the lower limit here, 0.24, to the lower limit here, we get 0.565, which is just a little less than the 5.7. That's reasonable. If we add the two upper limits, we get 0.7 or 0.615, which is greater than the total distance we could possibly have. Now, is that a contradiction? Is this range, is the top of this range and the top of this range, does this range and this range contradict our final result? Or rather, do these two ranges in some way contradict this range? Now, if we summarize the data for leaving, where we go from C to A, we find, first of all, distance from B to A, 10 out of 19 times it's 3, 9 out of 19 times it's 2, so from B to A, we get a distribution very similar to the distribution we got from A to B. And that's pretty much what we would expect, because there's no roundabout between A and B. Now, it came out almost identical, so we don't see any significant difference between those two distances. And apparently I drive the same going out as I do coming in. I don't weave more one way than the other. Between C and B, of course, there is a roundabout. And in this case, we see that 13 out of 19 times we got a 3. I'm sorry, between C and B going out, there's no roundabout. Coming in, there was a roundabout. So now, 13 out of 19 times, there was a difference of 3. I mean, we indicated 3 changes. And only 6 out of 19 did we indicate 4 changes, which means that our estimate of the mean distance is somewhat lower than it was before. So here's just an attempt to show our 95% area. And I estimated it goes between 0.32 and 3.4. Okay? And again, these are just ballpark estimates. They're not based on rigorous statistical analysis. I'll add that later if I have time. Okay, difference between C and A. This time, without the roundabout, 4 out of 19 times we got 5, 15 out of 19 we got 6. Before it was 3 out of 23 times we got 5, so we're somewhat more likely to get a 5 than we were before if we go by the trend or the indication of this data. And so here's our estimate for that situation. And it looks like distance CA is less than distance AC, less distance going out than coming in. At the 90% level, here are the stabs we have. On these two, the roundabout intervenes. On this one, the roundabout does not.